Hello everyone, welcome to the Learning Cubicle. In the last class, we have learnt about average speed, instantaneous speed, and even about some devices like odometer and speedometer. And today, we are going to learn another topic from the same lesson, motion. And I think you are familiar with the example that's being shown on the board over here. This is a case where you start from your home and go to school on two different occasions. In one occasion, you go from home to the stationery shop, purchase something, and then go to the school. So that is this way. And in another case, you directly go from home to the school. That is in this way. So there are two different situations, this one and this one. And we all know that this is what we call as the distance, because it is not the shortest and it is not in a particular direction. Whereas this is called as the displacement. Because it is the shortest between this and this points, the home and the school, and that's the displacement, and it is happening in a particular direction as well. Now, to cover this distance, you will definitely take some time. So that distance covered in some time, we have already discussed that as speed. And in the same way, we have this displacement. And for you to cover this, or for you to have this displacement, you will definitely take some time, and that is what we call as velocity. Velocity is nothing but the speed of a body, and that too in a particular direction. So speed with direction is what we call as velocity. That means it is the displacement of a body in some time. So velocity is equal to displacement of the body in some time. So displacement by time is what is the expression of velocity. Now, since velocity is also associated with direction, so we can understand, or we can say that velocity is a vector quantity. It is a vector quantity. Velocity is also a vector quantity, just like displacement. Just the same way, speed, the units are meters per second, kilometers per hour, and miles per hour. Even for velocity, it's the same. The SI units are meters per second, and the other units are kilometer per hour and miles per hour. So that is velocity. So velocity is nothing but the displacement of a body in some time. It can also be defined as the rate of change of motion in a specific direction. Means how quickly the body covers the distance, and that too in a particular direction, is what we get from velocity. Okay. Now let us try to understand, or try to compare these two quantities, speed and velocity. Okay. Let us quickly do that. So I am writing speed here, and I am writing velocity here. Speed, we have defined that it is the rate of change of motion, and whereas velocity, we define it as the rate of change of motion in a specific direction, or which also means this is distance covered in some time, and this is displacement of the body in some time. Here we don't associate any direction, so this is a scalar and this is a vector. Okay, and here in case of speed can never be zero. Speed can never be zero. Whereas, then what about velocity? Can it be zero? We have displacement. There are situations where the displacement is zero, isn't it? For example, if a body starts from one point and comes back to the same point, we know that the displacement of the body is zero. So can that be zero? Can we say that velocity will be zero when the displacement is zero? No, we cannot say that. Why? Because when we know that the body is moving, we cannot simply say that the velocity of the body is zero. It is quite impossible. The velocity of the body cannot be zero just like that. Then what? If the displacement is zero, still the body will have velocity? No, I don't say that also. So I am not saying that the displacement is zero means velocity is zero. At the same time, even though the displacement is not there, the velocity will still not be zero. No. Let us try to understand that with a simple example. Let us say that a body is moving in a circular path. Let us suppose that it has started over here and it has gone in this direction. This way it has gone and it has returned to the same point. Let us suppose. Okay. Now let us suppose the body is at this point. It is moving with, say, some velocity v1. Then its direction will be this. Now diametrically on the opposite side, you take another point where the body is. In that case, the body's movement will be in this direction. Now if you observe carefully, this direction and this direction are opposite to each other. Then if this is v1, can I say this as minus v1? Yes. Similarly, if I take the body over here, its direction is this. Say it is v2. Then diametrically opposite to that over here, the body's direction would be this. So if this is v2, can I say that this is minus v2? Yes. So if I add up all these velocities and find their average, then I will get v1 plus v2 minus v1 minus v2 plus v3 minus v3 plus v4 minus v4 plus and so on, plus v1 vn minus vn whole by n. So these all will get cancelled. v1 minus v1, v2 minus v2, v3 minus v3, v4 minus v4, vn minus n, and all of them get cancelled and you will get 0 by n, which is 0. So we cannot say that the body's velocity is 0, but the body's average velocity will be 0. Average velocity can be 0 when the body starts from one point and returns to the same point. Okay? And at the same time, speed can never be negative. It's always positive. Whereas velocity can be positive, can be negative, and also average velocity can be 0. Thank you.